and it's going to rise to the right. So this is going to be the end behavior of your graph. If this is a negative number in front of the x raised to an odd power, for example, negative 2x to the third, then it's going to rise to the left and fall to the right. You need to memorize these patterns, okay? Then if your exponent is an even number, so let's say it's a positive number, let's say it's 3x squared. So if this power is even, then your end behavior looks like a parabola. It's going to rise left and it's going to rise to the right. If it's a negative number in front of your variable that's raised to an even power, then it's going to fall to the left and fall to the right. So once you get your zeros, you're going to add these end behaviors to the far leftmost zero and the far rightmost zero. Also talked about in the video, I talked about multiplicity. Okay, so the video also talked about multiplicity, and this is just counting how many times your zero occurs. So when your zero occurs an odd number of times, meaning a 1 time, 3 times, 5 times, it's said to have an odd multiplicity, and it's going to cross the x-axis when you graph it. When it occurs an even number of times, like 2 times, 4 times, 6 times, then it's said to have even multiplicity, and it's going to be like a bounce, meaning it's not going to cross the x-axis. It's going to come in, it's going to touch the x-axis, and then it's going to turn around and bounce back up. Touch and turn. Yep. So my first example is going to be x to the third minus 2x squared minus 3x plus 6. And it's y equals, or f of x equals. The first thing you should do is, if you can factor it, then factor it to get your zeros. So I can actually factor this one by grouping. I'm going to go ahead and make a red group here and a blue group. The GCF of my red group is going to be x squared. I'm going to divide both of the terms by x squared, and then I'm left with x minus 2. My GCF of the blue group is going to be negative 3. And then again, I'm left with the same thing. Remember, when you factor by grouping, the answers you get when you divide must be the same. Now you're going to take the two GCFs, put them together, and then take the common factor, the x minus 2, and put it in another binomial. I'm now going to set each of my factors equal to 0. These are going to give me my x-intercepts or my zeros. Now, for the first one, I'm going to set x squared minus 3 equals 0, x minus 2 equal to 0. I'm going to solve this one by adding 3. X squared equals positive 3. I'm going to square root both sides, and I get x is equal to plus and minus the square root of 3.
Can we just square root x squared minus 3 and then get x plus 3x minus 3?
No, it's not factorable. All right, so now these are my 3 x-intercepts. They're also called solutions. They're also called roots, and they're also called zeros. So now what I'm going to do is these can turn into ordered pairs. So I would be graphing negative square root 3 comma 0, positive square root 3 comma 0, and 2 comma 0. I also need to go back and find my y-intercept. To find the y-intercept, I am going to set x equal to 0. Now, again, it's just the constant. So I'm going to set x equal to 0, and I'm plugging it into the original. So y equals 0 cubed, 2 times 0 squared, minus 3 times 0, minus 6, or plus 6. And then notice all of this is just a 0. So then I'm just left with my y-intercept, which is just the constant, 0, 6. So now I'm going to go ahead. Let's go back and identify my end behavior. My largest power is x to the third. So my end behavior here is going to fall to the left and rise to the right because it's based on an x to the third. Notice all of my x-intercepts or my zeros, all of them have a multiplicity that is odd. They all occur one time. So all of these are going to cross the x-axis when I graph them. And you're going to see what I'm talking about once I get them on the graph. So let me go ahead and make a coordinate plane. Now I'm going to approximate the square root of 3. So if you think about it, the square root of 3 is in between these two perfect squares. So it's about 1.7. So I'm going to be graphing in between 1 and 2, and negative 1 and negative 2. So I'm going to put a point here on negative 1.7, positive 1.7, and then positive 2. I'm also going to put a point on my y-intercept, 1, 2, 3, 4, 5, 6. I'm going to also now add in my end behavior. So on my far left point, it's falling. On the far left, it's rising. The square root of 1 is 1. The square root of 4 is 2. And I know 3 is closer to 4. So I'm going to say it's a little bit more than 1.5. Okay, so now we need to figure out how this graph is going to go. Now, when you're using your graphing utility, you can figure out additional points in between the zeros. However, you can also use synthetic division and use your remainder theorem to get additional points. So for example, let's say I wanted to get an additional order pair, and I wanted to figure out what the order pair for x equals 1 is. So I could also do synthetic division to get an additional order pair. So what I would do is synthetic, and then x equals 1. I want to know where my point in this section is going to go. So I'm going to plug in a 1 to see how high it's going to go. So I'm going to go ahead and do synthetic with the 1, and I get 1, negative 2. I'm taking the coefficients. Remember, you got to account for every single coefficient. So I'll bring down. I'm going to multiply. I'm going to add the column. I'm going to multiply. I'm going to add the column. I'm going to multiply and add the column. So 1, 2 would be a point on my graph. So now I'm going to connect my points. So it's going to come up here to the y-intercept. It's going to come down, hit that point, hit this point. It's got to cross through and then come back up. Now, I don't know how low it's going because I didn't do another synthetic division. How low this went just by looking at the other things. But know that at all of these zeros, it's crossing the x-axis. It's not touching and turning. So number 2. The equation is going to be y equals x to the third plus 2x squared. I'm going to factor out a GCF here. I can't do anything else with this. So I could factor out an x squared, and then I'm left with x plus 2. I'm setting this equal to 0. I'm going to set x squared equal to 0 and x plus 2 equal to 0. I'm going to square root this one. Now, notice technically what I'm getting out of this is plus and minus 0. But there really is no positive and negative 0. So what you need to know is this has a multiplicity of 2. So this is going to be a bounce or a touch and turn when I graph it. It's not going to cross through the x-axis at 0. This one I'm going to finish solving. This is my other x-intercept, or my other 0. So I have 0, 0, and negative 2, 0. My y-intercept, if I plug in x equals 0, notice you're going to get 0, 0. So if you set x equal to 0, y equals 0 to the third, 2 times 0 squared, just gives you 0. So my y-intercept is also 0, 0. So let's go ahead and create our coordinate plane here. And I'm going to graph negative 2. I'm going to graph 0, 0. Now, let's go back and look at our end behavior as well. It's also an x to the third still. So it's falling left, rising right. So on my leftmost 0, it's going to be falling. And this one, it's going to be rising. Now, I need to figure out what's happening in between here. So I can do synthetic division with negative 1 to see how high my graph is going to go. So I can do negative 1. And then I got to have all of the coefficients. So x to the third has a 1. X squared has a 2. I don't have an x term, and I don't have a constant. So I got to fill those gaps with zeros. I'm going to bring down the 1. I'm going to multiply, add the column, multiply, add the column, multiply. My ordered pair that I'm going to graph, I'm going to take the remainder and what I divided by. So I'm going to be graphing negative 1, positive 1. So my graph is only going to go up a little bit, and then it's going to come back down. It's bouncing at the 0. It doesn't cross, and then it goes right back up again. So again, this was my function, y equals x to the third minus 6x squared plus 9. My end behavior is an x cubed, so it's falling to the left and rising to the right. I'm factoring out a GCF of x. Then what remained was a perfect square trinomial, and then I could factor that into x minus 3 times x minus 3. Set each of the zeros, or each of the factors equal to 0, and then we get x equals 0, x equals 3, x equals 3. Because x equals 3 occurred 2 times, it's got an even multiplicity, so it's going to bounce on the x-axis, whereas at x equals 0, it's going to cross. So I'm going to do synthetic division, and I'm going to plug in positive 1, and then I'm also going to do it again with 2, just to get 2 additional ordered pairs to see what's going on in that gray area. So again, I'm going to put the original coefficients in here. I'm going to hold a place for the constant with a 0. So now I'm going to bring down the 1, multiply, add the column, multiply, add the column, multiply, and it's got a remainder of 4. So 1 comma 4 is an ordered pair I'm going to graph. Then I'll do the same thing for 2, bring it down, multiply, add the column, multiply, add the column, multiply, and another ordered pair I can graph will be 2, 2. So let me go ahead and graph both of these ordered pairs. So I'm going to graph the ordered pair 1, 4. So it'll be up here, and then 2, 2. So then you can see it's going to go up here to the 1, 4, down, hit 3, and bounce back up. And there's your graph. The next example, the y equals x to the fourth minus 5x squared plus 4. This end behavior is even, and it's a positive even, so it's going to be rising left and right. So what I can do here is factor this. It's going to turn into x squared minus 4 and x squared minus 1. Because the factors of positive 4 that give me negative 5 are going to be negative 4 and negative 1. Notice both of these are the difference of 2 squares. So I can factor it into x plus 2, x minus 2, x plus 1, x minus 1. Notice I should be getting 4 factors here. unless it ended up being something squared. So then solve each one. So x plus 2 equals 0, x minus 2 equals 0, x plus 1, x minus 1. Solve each one. This one gives me negative 2, positive 2, negative 1, positive 1. These are all my x-intercepts, which are also my zeros. Notice my y-intercept, this one has a constant. If I plugged in zeros into my original, 0 to the 4th, 5 times 0 squared, plus 4, my y-intercept is just going to be the ordered pair 0, comma 4. So now I'm going to graph all of this. I'm also going to add in my end behavior, and then I'm going to see how it moves. So let me go ahead and make my coordinate plane here. Add in 1, 2, 1, 2, 1, 2, 3, 4. So I'm going to graph negative 2, negative 1, positive 1, positive 2, and 0, comma 4. My end behavior, it's going up on both ends because it was x to the 4th. Now, this one would be a little bit more challenging to find the additional points because what we would need to plug in is 1.5 and negative 1.5. So again, just look for the multiple choice. You know it's going to be going down because it had to cross, back up, down, and up again. You could do synthetic division with, I would do it as a fraction, 3 over 2. And then you got to hold the place. So it was an x to the 4th, which was 1, no x cubed, negative 5, no x term, and then the constant. So that would have been your setup for your synthetic. Actually, once you do the whole thing, it's going to end up being negative 2 and 3 over 16. So if you thought that this is like negative 1, negative 2, I hit it about right, just estimating it.
Wait, I plugged in.
So for example, this is number 10 in the notes, and it had f of x is equal to x squared plus 3 times x minus 1 squared plus, or times x plus 4. When it's already given to you in factored form, all you're going to do is take your factors, set them equal to 0. Now notice this one is twice. So x minus 1 equals 0, x minus 1 equals 0, and then x plus 4 equals 0. So here, once I subtract, square root, I get x equals plus and minus I radical 3. Now on the test, you're going to list this as a 0. It's not an x-intercept. And then here, this one will give you x equals 1, x equals 1, x equals negative 4. Notice this one has a even multiplicity, so it's going to be a bounce. Okay? These are all odd multiplicities, so they're going to cross. Now, my y-intercept, I have to plug in x equals 0. I can't just look for a constant. So for my y-intercept, I'm setting x equal to 0. So y equals 0 squared plus 3, 0 minus 1 squared, and 0 plus 4. This gives me 3. This gives me positive 1 when I square negative 1, and then 4. And then once I multiply 3 times 1 times 4, I get 12. So my y-intercept is 0, 12. So now, let me go ahead and put this all on my graph. Now, let's go back and look for my end behavior. Notice in this one, I've got two zeros. This is going to give me 2 zeros, and this is going to give me 1. So this is going to be based on an x to the 5th, because I have 2, 3, 4, 5 zeros here. So my end behavior is going to end up, yep, because it's an odd exponent and the number in front of x squared is positive. So I'm going to go ahead and add these numbers to my graph. So positive 1 and then 1, 2, 3, 4. And then negative 12 we'll say is up here, or positive 12 is up here. So my y-intercept is here. I've got a 0 here and here. My end behavior, falling, rising. Now, what you would do here is do some synthetic division to get an order pair to see how high this goes. You could plug in -1, -2, -3. If you plug in, and you can't do synthetic, you have to actually plug it in because it's not in a polynomial form. Everybody with me on that?
So you do the -1 squared plus 3, and then
Yep. Okay, and then once you do that, one of the order pairs, the highest the graph goes is going to be the order pair -3 and 192. It's super high. I don't expect you, without a graphing utility, to figure out if the -1 was the highest, the -2. Just show me that it does go up above and then come back down and then bounce on the 4. On the 1, sorry. And that would be your graph. Because this would go way up in the sky, up to 192.
That's the bounce.
The bounce is here. Because 1 occurred 2 times.